You hear the words interstellar comet and you think cold rock, dead ice, ancient debris, something tumbling through the void until it hits our gravitational well. But 3i Atlas is not playing by those rules. July 1st, 2025, Atlas telescope in Chile picks up a signal, 4.5 astronomical units out, moving at 61 kilometers per second. Within 24 hours, the numbers confirmed it. Hyperbolic trajectory, orbital eccentricity, 6.141. That is not just hyperbolic. That is the highest eccentricity of any interstellar object ever recorded. 1i Oumuamua clocked in at 1.2. 2i Borisov hit 3.4. 3i Atlas is running at 6.141. The path so extreme it looks straight, not curved, a line cutting through space. The trajectory itself raised questions immediately. Retrograde orbit tilted 175 degrees from the ecliptic. That means within 5 degrees of the planetary plane, a 1 in 500 chance for random orientation. Then the approach distances. October 3rd, 2025, it passes Mars at 30 million kilometers. Minimum orbit intersection distance. With Mars only 2.7 million kilometers. October 29, it hits Perihelion at 1.36 astronomical units, just inside Mars orbit. November 3rd, it flies past Venus at 97 million kilometers. December 19th, it comes within 269 million kilometers of Earth. March to 16th, 2026, it swings by Jupiter at 54 million kilometers, every major planet in its path. The statistical probability of those close approaches with that trajectory alignment is less than 0.005%, 1 in 2,000. Those are not random walk numbers. If you value documented astronomy and astrophysics history like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. Also, this script is researched and factual using sources from the Minor Planet Center Orbital Database, updated through September 23rd, 2025, Gahund. Peer-reviewed studies in the Astrophysical Journal letters, including the JWST and IR spec analysis by Martin Cordner and team published August 25th, 2025, and VLT spectroscopy data from Rohan Rahatgaonkar's team, also from August 2025. These are deep institutional sources tracking every photon and trajectory point. Now back to the information. The object was first spotted by the Asteroid Terrestrial Impact Last Alert System, one of 5 telescopes designed to catch near-Earth objects. But this was no asteroid. Pre-discovery observations traced back. Zwicky Transient Facility at Palomar caught it June 28th to 29th, then June 14th to 21st. Atlas itself had images from June 5th to 25th. It was passing in front of the Galactic Center. Dense star fields made detection nearly impossible. Amateur astronomer Sam Dean found those early frames. The comet was hiding in plain sight, moving from the direction of Sagittarius, the galactic center, the thick disk region of the Milky Way. That origin matters, because the thick disk is where the galaxy keeps its oldest stars. Stars formed when heavy elements were scarce. When the universe was younger, Matthew Hopkins at Oxford analyzed the galactic velocity components. Radial velocity, negative 51 kilometers per second away from galactic center. Vertical velocity, positive 18.5 kilometers per second upward through the galactic plane. That vertical component is unusually high. It means the comet belongs to either the thin disk or thick disk population. Hopkins' team ran the statistics, 68% confidence interval. 3i Atlas is between 7.6 and 14 billion years old. An independent analysis by Astor Taylor and Daryl Seligman placed it at 3 to 11 billion years. Either way, it predates our solar system. 4.6 billion years is nothing to this object. It has been drifting through interstellar space, possibly since cosmic noon. When star formation peaked, when the galaxy was young, the chemistry backed this up, but delivered new problems. James Webb Space Telescope observed 3i Atlas, August 6th, 2025. Distance 3.32 astronomical units from the Sun. NIRSpec instrument captured spectra from 0.6 to 5.3 micrometers. What it found rewrote the textbook on cometary composition. Carbon dioxide dominated the coma, 129 kilograms per second mass loss rate. Water vapor only 6.6 kilograms per second. Carbon monoxide, 14 kilograms per second. Carbonyl sulfide, 0.43 kilograms per second. The carbon dioxide to water mixing ratio came in at 7.6 to 1. That is the highest ever observed in a comet. 4.5 sigma above the trend line for long period and Jupiter family comets. Normal comets are water rich. 3i Atlas is carbon dioxide rich by an order of magnitude. Spherex Space Observatory confirmed it. Observations, August 8th to 12th, 2025. Extended carbon dioxide coma spanning at least 348,000 kilometers in radius. 95% carbon dioxide by mass, 5% water. Almost no carbon monoxide detected by SphereX, though JWST found traces. This is not how solar system comets behave. Water ice sublimates at higher temperatures. Carbon dioxide sublimates at around 100 Kelvin. At 3 to 4 astronomical units from the Sun, this object should not be outgassing carbon dioxide this aggressively. The prevailing theory: it formed beyond the carbon dioxide frost line in its home system, far from its parent star where carbon dioxide ice dominates. Then it got kicked out. Close encounter with a giant planet or a passing star. Gravitationally slingshot into interstellar space where it drifted for billions of years. But the carbon dioxide was just the start. Very large. Telescope in Chile used the X-Shooter and UVES instruments. Observations from July 4th to August 21st, 2025. Heliocentric distance 4.4 down to 2.85 astronomical units. They detected nickel emission lines, atomic nickel vapor at 4.6 grams per second by August 21st, then cyanide emission, 17.6 grams per second. The nickel detection was early, too early. Nickel and iron are cosmic twins, forged together in supernova cores, found together in every natural space object ever studied. Meteorites show nickel-iron ratios. Asteroids show nickel-iron together. Comets that sublimate metals show both. But 3I Atlas showed nickel without iron. The VLT team searched. No iron lines detected. The iron could be there below detection threshold, or the nickel is being released through exotic chemistry. Nickel tetracarbonyl breakdown, photon-stimulated desorption, metallated organic compounds, processes never before observed in space. The nickel production scaled steeply, power law index negative 8.43. As the comet got closer to the Sun, the nickel emission exploded. 25-fold increase in 1 month. Cyanide followed. Power law index negative 9.38. These are not sublimation curves. Direct ice sublimation does not produce these slopes. The VLT team proposed low activation energy release from dust, thermolysis of nickel-rich nanophases. Maybe nickel carbonyl complexes breaking down under ultraviolet light and mild heat. If true, this is chemistry from an environment unlike our solar system, an environment with different radiation exposure, different formation conditions, material that has been space-weathered for billions of years in the interstellar medium. Lowell Observatory caught cyanide August 22nd, very large. Telescope confirmed it August 21st, and also detected atomic nickel vapor. The concentrations were similar to solar system comets observed at comparable distances, but the sequence was wrong. Nickel before cyanide. Usually cyanide shows up first. The chemistry timeline did not match expectations. And there was another missing piece. No detection of atomic oxygen. No dicarbon. No tricarbon. No amino radicals. MDM Observatory in August also found no dicarbon or tricarbon. 3I Atlas is one of the most carbon chain depleted comets known. The carbon-2 to cyanide ratio upper limit places it in a category of its own. Then the size problem hit. Hubble Space Telescope imaged 3. I-Atlas, July 21st, 2025. Distance 445 million kilometers from Earth. Teardrop-shaped cocoon of dust. The nucleus could not be separated from the coma. Estimated diameter between 0.32 and 5.6 kilometers. Most likely under 1 kilometer. But the object was showing massive outgassing. 150 kilograms per second total mass loss. At that rate, with that much activity, the nucleus should show non-gravitational acceleration. The outgassing acts like a rocket, pushes the comet off its predicted path. This is standard cometary behavior. September 24th, 2025, Avi Loeb, Richard Cloete, and Peter Verres published astrometric analysis. 4,022 observations from 227 observatories, May 15th to September 23rd. They compared observed sky positions to pure gravitational trajectory, upper limit on non-gravitational acceleration, 0.028 arcseconds over 4.5 months. Translation: the comet showed no measurable rocket effect. Zero deviation from gravity, only path. Given 150 kilograms per second mass loss and 440 meters per second outflow speed from the Webb data, the numbers demand one conclusion. The nucleus must be massive, over 33 billion tons, diameter larger than 5 kilometers, 3 to 5 orders of magnitude more massive than 1I Oumuamua and 2I Borisov. The mass anomaly creates a population problem. Interstellar objects follow a size distribution. Small objects are common. Large objects are rare. Power law distribution. To get one object the size of 3I Atlas, you should find 100,000 objects the size of 1I Oumuamua first. We have found exactly 2 previous interstellar objects. The reservoir of rocky material in interstellar space, calculated from exoplanet system ejection rates, cannot support the detection rate of a 5-kilometer plus interstellar object. The mass of 3I Atlas requires either an unrealistic interstellar mass reservoir, or we are seeing a population we did not predict. A class of massive ancient interstellar objects that challenges the models. The polarization data added another layer. Zachary Gray's team observed 3I Atlas through August and September. Linear polarization measurements across multiple wavelengths. The comet showed extreme negative polarization, lower than any known solar system comet or asteroid. The inversion angle where polarization switches from negative to positive was also anomalously low. The combination of low inversion angle and extreme negative polarization has never been observed in any natural solar system body. 2I Borisov had normal polarization for an interstellar comet. 3I Atlas is off the chart. Different dust grain properties, different scattering behavior, material that formed or evolved under conditions we have not encountered. The Hubble image from July showed something strange, a dust tail pointing away from the sun, standard cometary feature, but the tail extended forward toward the sun as well. A sunward glow, not typical. In comets, dust pushed by solar radiation pressure trails behind. Small particles get blown back, large particles resist and form diffuse clouds. But 3I Atlas had a forward extension. The only explanation, large dust grains on the sunward side outgassing at high speed, or the viewing geometry foreshortened a standard tail. By end of August, Gemini South telescope showed the anti-solar tail had grown, 30 arcseconds angular length, 56,000 kilometers. The tail was becoming visible as the comet approached perihelion and viewing angles changed. Then, in early September, the color shifted. Michael Yeager and Gerald Raymond captured images September 7th during the total lunar eclipse. 3I Atlas was glowing green. Every previous spectroscopic study showed reddish color from dust scattering. The Atlas survey team tracked brightness evolution. Early on, the comet brightness increased with power law index of 2.4, steeper than normal. Then as it got closer, the growth moderated to 1.2. The team interpreted this as a shift. Initially, sunlight scattered off reddened dust lifted from the surface. Then, as activity increased, small optically bright icy grains formed. Changed the opacity of the material shedding off the comet. The green glow remained unexplained. No detection of the usual suspects that glow green when heated. No decarbon. No obvious source. The color change indicated something in the composition was reacting to solar heating in an unexpected way. By September 21st, 3I Atlas reached magnitude 12.9, still 100 times fainter than other comets visible at the time, but brightening. A coronal mass ejection launched from the Sun September 19th. NASA Enlil model predicted impact on 3I Atlas September 24th or 25th. An extremely rare event. Interstellar comet hit by a CME while under observation. The solar-wind interaction would provide data on the coma structure and magnetic field interaction. Spacecraft across the solar system prepared to observe. October 3rd, 2025 became the critical date. 3I Atlas passes Mars at 29 million kilometers. Mars reconnaissance. Orbiter. High-rise camera can image at 30 kilometer per pixel resolution, 30 kilometers per pixel at 0.195 astronomical units. That resolution could separate the nucleus from the dust cloud, could confirm the size, could settle whether this is a 5-kilometer plus behemoth or something smaller with unusual dust properties. Chinese Tianwen-1 orbiter, Emirates Hope orbiter with the ultraviolet spectrometer, Mars Express high resolution, stereo camera. ExoMars, trace, gas orbiter color, and stereo surface. Imaging system, Omega spectrometer, Spicum spectrometer, Nomad spectrometer. Every instrument at Mars will turn to 3I Atlas, distance 30 million kilometers. Close enough for real data. Close enough to see details Earth-based telescopes cannot resolve. The Mars flyby also raised another question. Minimum orbit intersection distance 2.7 million kilometers. That is the closest 3I Atlas gets to the entire orbit of Mars around the Sun. Avi Loeb calculated that a velocity change of 10 to 15 kilometers per second during September could bring the closest approach to zero, could target Mars directly. Natural cometary outgassing produces kicks of about 0.4 kilometers per second, based on Webb telescope data. Not enough. The carbon dioxide plume extends 350,000 kilometers based on SphereX observations. Beyond that, the solar wind ram pressure confines it. To reach Mars from the plume without maneuvering would require a distance 100 times larger than the plume extent. The numbers do not close for natural transfer of material to Mars. If anything from 3I Atlas reaches Mars independently, it implies directed motion. Precursor probe, ejected object with higher velocity than outgassing allows. Loeb and team suggested HiRISE could search Mars orbit for precursor objects. Objects 100 meters or smaller, too small for Earth telescopes to detect by reflected sunlight, but visible to HiRISE if they are there. October 3rd is a blind date. The comet arrives. Mars is watching. If something unexpected shows up, the implications shift. This is where documentary evidence must separate from speculation. The observations in October will provide facts. Either the nucleus is massive and naturally formed, or the size and behavior point to something else. The data will constrain the possibilities. That is what makes this moment critical. The window to observe is narrow, the information irreplaceable. October 29th to 30th. 3I Atlas reaches perihelion, 1.36 astronomical units between Earth and Mars, but Earth will be on the opposite side of the Sun. Solar conjunction. The comet disappears from Earth view. Solar elongation, 12.8 degrees, impossible to observe from Earth. This is when comets typically become most active. Maximum heating, maximum outgassing, maximum risk of fragmentation. And we cannot see it from Earth, but other spacecraft can. Jupiter, icy moons. Explorer JUICE, best positioned, 18-degree elongation from the Sun as seen from Earth. Communications with Earth uninterrupted. JUICE will be 0.23 astronomical units from 3I Atlas. Janus camera 115mm aperture, 620 kilometer resolution at closest approach. Not as sharp as HiRISE, but covering a larger field of view. The NIR spectrometer. The ultraviolet spectrograph, the particle sensor. JUICE will observe in November when the comet is highly active and hidden from Earth. NASA Europa Clipper also in position. Ultraviolet spectrograph coordination with JUICE. Twin instruments on separate spacecraft. Stereo observations of the same event. The coma dynamics, the gas emission profiles, the tail structure, the interaction with solar wind, all of this captured while Earth telescopes see nothing. The Psyche spacecraft already had its chance. September the 4th, 2025. Distance 0.302 astronomical units. Closest approach before Mars. Psyche imaging and spectrometry from that angle provided one data set. Mars adds another. JUICE adds a third. 3 vantage points, 3 distance scales, 3 instrument suites, triangulating on one object. November 25th, JUICE sends back data, but the data arrives February 2026. JUICE uses its high-gain antenna as a heat shield when close to the Sun, transmitting on medium-gain antenna at lower rate, far side of the Sun from Earth. The data pipeline is slow. We will not know what JUICE saw until months later. The comet will have already moved on. A delay is the price of deep space observation, but the data when it comes will be worth the wait. Perihelion observations from a spacecraft that could see what Earth could not. December, the comet re-emerges, visible before sunrise, solar elongation increasing, moving through Virgo and Leo, magnitude dimmer than 12, fading as it moves away from the Sun, Hubble scheduled to perform ultraviolet spectroscopy, sulfur to oxygen ratio, gas emission composition, monitoring as it exits the solar system, JWST scheduled for second observation, post-perihelion chemistry. Did the carbon dioxide to water ratio change? Did new ices sublimate from deeper in the nucleus? Did the heat alter the surface composition? 2I Borisov showed a composition shift after perihelion. Water source seemed to run out. Carbon monoxide remained. 3I Atlas might follow a similar pattern, or it might not. The pre-perihelion composition was already anomalous. Post-perihelion could be even stranger. December 19th, closest approach to Earth. 1.8 astronomical units, 269 million kilometers, not close enough for amateur telescopes, not bright enough for naked eye, professional observatories only. The window from December into early 2026 is the last chance. After that, 3I Atlas accelerates outward. Magnitude drops, signal fades. By April 2026, it crosses beyond Jupiter. Velocity 59 kilometers per second relative to the Sun, leaving the solar system forever, never to return. Hyperbolic trajectory guaranteed. Eccentricity 6.141 means unbound. Escape velocity exceeded by a massive margin. The Vera C. Rubin Observatory will be watching. Commissioned 2025. First year of operation found over 2,000 new asteroids in 10 hours. More data than all previous optical observatories combined. Rubin will detect interstellar objects before they get deep into the inner solar system. 3. I-Atlas was discovered at 4.5 astronomical units. Rubin could find similar objects at 10 or 20 astronomical units. More warning time, more observation time, better trajectory data earlier. The detection rate for interstellar objects will increase. Hopkins' model predicted we might find 50 objects over Rubin's decade-long survey. Some similar in size to 3I Atlas, some smaller. Each one a sample from a different star system. Each one carrying information about planetary formation in regions of the galaxy we cannot visit. 3I Atlas already changed the equations. Size distribution needed revision. Chemical composition needed new categories. Trajectory statistics needed new baselines. The polarization properties needed explanation. The missing iron with present nickel needed models. The extreme carbon dioxide dominance needed formation scenarios. The mass anomaly needed population dynamics. One object generated a dozen new research questions, and it will be gone in months. That is the nature of interstellar visitors: fleeting, unique, irreplaceable. The thick disk origin, if confirmed, means we are seeing material from the early galaxy. Stars with low metallicity, protoplanetary disks with less heavy elements than our solar system, planets and comets forming under different chemical constraints. If 3. Atlas is 7 to 14 billion years old, it formed when the universe was less than 7 billion years old, when the Milky Way was assembling, when stellar populations were younger, when supernova rates were different. It has traveled through interstellar space for billions of years, exposed to cosmic rays, bombarded by high-energy particles, surface chemistry altered by radiation, ice structure modified, dust grains processed. The object we are observing now is not the pristine nucleus from its birth system. It is a space-weathered relic, baked by radiation, sculpted by impacts, carrying the signature of both its formation environment and its long journey. Yi Yangguo's team traced the orbit backward. 3 I-Atlas passed within 1 parsec of 25 known stars in the past 10 million years, 3.3 light years. Close approach, gravitational perturbations from those encounters, velocity changes, trajectory deflections. The current path is the result of billions of years of gravitational interactions with stars, nebulae, molecular clouds. The Milky Way stirred this object, passed it around, and eventually sent it toward our solar system, not by design, by the statistics of orbital mechanics over deep time. 10 billion years is enough time for an object to wander across significant fractions of the galactic disk, enough time for random walks to look directed. The Avi Loeb question hangs in the background. Is 3 I-Atlas an unusually massive comet with unusual chemistry on an unusual trajectory? Or is it something else? Technology, a probe, an artifact. Loeb put it on his scale. 0 is definitely natural. 10 is definitely artificial. He ranked it a 4 in August. The ranking could go to 0 with more data, or it could go to 10. The facts matter. The alignment with the ecliptic, 1 in 500. The close approaches to multiple planets, 1 in 2000. The lack of non-gravitational acceleration, despite massive outgassing, anomalous. The nickel without iron, unprecedented. The carbon dioxide to water ratio, extreme. The polarization, unique. The size versus detection rate, statistically problematic. Each fact is documented. Each measurement is real. The interpretation is where the debate begins. Most astronomers settle on natural explanation, exotic comet, unusual but not impossible. The chemistry can be explained by formation conditions. The trajectory can be explained by galactic dynamics. The size can be explained by population uncertainties. The missing iron can be explained by detection limits or nickel-carbonyl chemistry. Every anomaly has a proposed natural mechanism, untested, speculative in some cases, but natural. The alternative technological explanation requires accepting that we are being visited, that an object was sent, that it targeted the inner solar system, that it came close to multiple planets by design, not chance. Extraordinary claim, requires extraordinary evidence. The evidence so far is circumstantial, suggestive, not conclusive, but the door remains open because the data is incomplete. The high-rise images will constrain the size. The JUICE observations will reveal perihelion behavior. The December spectroscopy will show post-perihelion chemistry. The trajectory data will extend through early 2026. More numbers, more constraints, more facts. And then 3, I-Atlas is gone. The conclusions we draw will be based on a few months of observations, a handful of data points, a single pass through the solar system. That is all we get. That is all we will ever get. One chance to understand what this object is, where it came from, what it means. The solar wind hit 3I Atlas on schedule. September 25th, 2025, the coronal mass ejection, a wave of charged particles from the sun, washed over the comet's coma. Ground-based radio telescopes and deep space probes monitored the interaction. The results were immediate and confounding. The comet's vast carbon dioxide coma, normally a diffuse cloud, did not simply ripple. It compressed. It formed a distinct bow shock, a magnetic boundary, far sharper and more defined than models predicted for a non-magnetic body. The standoff distance of the shock wave was smaller than expected, implying a higher internal pressure within the coma or an interaction with an intrinsic magnetic field generated by the nucleus itself. Comets are not supposed to have magnetospheres. They are dirty snowballs. But the data from the Solar and Heliospheric Observatory, or SOHO, showed a magneto-tail-like structure trailing behind 3I Atlas for nearly 12 hours after the impact, a structure that required a coherent internal field to form. This was anomaly number 8 or 9. The list was growing too long to track. The world's astronomical community held its breath for October 3rd. The Mars flyby was no longer just an opportunity for high-resolution imaging. It was a crucible. Every anomaly, the mass, the chemistry, the trajectory, the magnetic interaction, pointed to an object that defied classification. The fleet of orbiters at Mars represented humanity's closest robotic sentinels. If 3I Atlas was going to reveal its true nature, this was the moment. The commands were sent. Antennas turned. Cameras cooled to operating temperature. The 29 million kilometer intercept was on. The first data packets trickled back to Earth through the Deep Space Network. The Emirates Hope orbiter was first. Its ultraviolet spectrometer confirmed the extreme carbon dioxide dominance and the lack of atomic oxygen at close range. No surprises there, just confirmation of the bizarre. Then came the data from the ExoMars Trace Gas Orbiter, its NOMAD instrument. Designed to sniff out trace gases in the Martian atmosphere, tasted the comet's coma. It found the expected carbon dioxide, the water, the carbon monoxide, but it also found traces of sulfur hexafluoride and tetrafluoromethane, complex, heavy industrial gases. On Earth, they are man-made, used in electrical insulation and manufacturing. In space, their natural formation requires conditions of temperature and pressure not known to exist in protoplanetary disks. The detection was at the very edge of the instrument's sensitivity, just a few parts per billion. It was flagged as a potential instrument error, a ghost in the machine, but it was logged. Then came the high-rise data from the Mars Reconnaissance Orbiter, with the highest resolution optical instrument ever sent beyond Earth orbit. The files were large. The processing took hours. When the first images resolved on screens at the Jet Propulsion Laboratory, the mission control room fell silent. There was no teardrop cocoon of dust. The intense outgassing seen from Earth was not a uniform shroud. At a resolution of 30 kilometers per pixel, HiRISE A saw the source. The nucleus was not a sphere. It was not a potato-like rock. It was a sharp, angular object, roughly triangular in its two-dimensional projection, with a length of at least 8 kilometers and a width of 5. Its surface was not the dark, mottled gray of a typical cometary nucleus. It was darker than coal, absorbing over 99.9% of the light that hit it. Vantablack dark, and it was not uniform. The images showed faint geometric patterns across the surface, a grid-like structure of faint lines, barely visible against the profound blackness. The outgassing was not coming from the entire surface. It was emanating from 3 specific points, one near each vertex of the triangular shape. These were not diffuse jets. They were highly collimated plumes, firing out into space with precision. The lack of non-gravitational acceleration finally made a terrifying kind of sense. If you have 3 powerful rocket engines on a massive triangular frame, and you fire them with equal and opposite thrust vectors, the net force is 0. The object stays on a purely gravitational path, even while expelling 150 kilograms of gas every second. The high-rise images did not resolve engines. They resolved the points of origin for the plumes. The implication was enough. Avi Loeb's team at Harvard ran the numbers again. The search for precursor objects in Mars's orbit came up empty. No 100-meter probes, no debris field, just the single, massive, dark object. Loeb revised his scale. 3I Atlas was no longer a 4. With the geometric shape, the grid-like patterns, and the impossibly balanced collimated jets, he moved his assessment to a 7. The line between natural explanation and extraordinary evidence had been crossed. The burden of proof was shifting. It was now on the natural origin camp to explain how galactic dynamics could form an 8-kilometer Parge Vantablack. Triangular rock with 3 perfectly balanced exhaust plumes and grid lines on its surface. The scientific community fractured. Papers appeared online within days. One team proposed the shape was a result of a catastrophic collision and subsequent reshaping by interstellar radiation. Another suggested the plumes were caused by the explosive sublimation of deeply buried volatiles through crystalline fissures in the nucleus. No theory could account for all the observations simultaneously. The grid lines were dismissed as imaging artifacts. The industrial gases detected by Nomad were written off as instrument noise. The established narrative strained to contain the data. October 29th arrived. 3i Atlas reached Perihelion, its closest point to the Sun, and disappeared from Earth's view into the solar glare. A collective blindness fell over terrestrial observers. The moment of maximum stress, maximum heating, was happening in silence, but not in darkness. 200 million kilometers away, the Jupiter Icy Moon's explorer, JUICE, was watching. Its Janus camera, its ultraviolet spectrograph, its particle sweep noise, all trained on the object as it rounded the Sun. Europa Clipper, on its own trajectory, provided a second angle of observation. For the next several weeks, humanity's only knowledge of the object would be recorded on solid-state drives aboard 2 distant spacecraft. The information was being gathered, but it was locked away, traveling at the slow speed of deep space data transmission. The comet re-emerged from behind the Sun in early December, fainter, moving faster now on its outbound leg. The first ground-based telescopes to get a clear view were in Australia and Chile. The green glow was gone. The coma appeared smaller, more condensed. The overall brightness had dropped more than expected. Had Perihelion exhausted its volatile supply? The James Webb Space Telescope and Hubble turned their gaze back to the visitor for their post-Perihelion follow-up. The JWST data was shocking. The carbon dioxide was still there, but the outgassing rate had fallen by 90%. The water vapor was gone. The carbon monoxide was gone. The nickel emission, however, had increased tenfold, and it was no longer alone. The spectrographs now showed clear, unambiguous emission lines for iron, chromium, and titanium. Metals that require immense temperatures to vaporize were now boiling off the surface of the object as it moved away from the Sun and cooled down. The sequence was backward. The chemistry was impossible. The VLT in Chile confirmed the detections. The ratios were strange. Far more nickel than iron. Significant amounts of titanium, an element not typically seen in cometary spectra. The comet was not dying, it was changing its state. February 25th, 2026. The first high-priority data packets from JUICE's Perihelion observations finished their long journey to the European Space Operations Center in Darmstadt, Germany. The telemetry was clean. The Janus camera images were decompressed. The scientists who saw them first did not speak. They stared. The images, taken at a resolution of 620 kilometers per pixel, showed 3i Atlas during peak heating. One of the 3 plumes had shut down completely. The other 2 had swiveled. They were no longer firing in a way that would balance their forces. They were now firing in the same general direction, creating a net thrust, a course correction, a small one, but deliberate. The JUICE data included Doppler shifts in the gas that allowed for a velocity calculation. The change was only a few dozen meters per second. Not enough to radically alter its interstellar trajectory, but enough to refine its path through the outer solar system, a path that would now take it closer to the trajectory of the Voyager 1 spacecraft, a statistical improbability piled on top of a mountain of improbabilities. The JUICE particle counter data added another layer of impossibility. During a brief burst of activity at Perihelion, the instrument had detected complex polymers in the coma, long-chain molecules with repeating metallic and carbon units, metallocenes, organometallic compounds. The kind of structures that on Earth are synthesized in chemical engineering labs for use as catalysts and high-temperature polymers. They were not the building blocks of life. They were the building blocks of industry. The Nomad detection of industrial gases was no longer an anomaly. It was a corroborating data point. By April 2026, 3i Atlas was beyond Jupiter's orbit, fading rapidly. The Vera C. Rubin Observatory, in its first year of operation, tracked the faint point of light until it was indistinguishable from the background noise of the galaxy. It was gone, and it left behind a revolution. The debate was no longer about whether 3i Atlas was a strange comet. The debate was about what it was and why it had come. The consensus settled on 2 irreconcilable positions. The first, the conservative view, held that 3i Atlas was a natural object from a type of stellar system so alien to our own that we lack the physics to understand its formation, a system born in the ancient, metal-poor, thick disk of the galaxy, where chemistry followed different rules, a place where planets formed from carbon-rich, water-poor material, creating bodies that behaved in ways our models could not predict. The shape, the jets, the chemistry, all were extreme but natural, products of a billion-year journey through this galaxy. The second position, articulated most forcefully by Loeb, but now supported by a growing number of physicists and astronomers, was that 3I Atlas was an artifact, a probe, ancient, silent, and incredibly advanced. Its purpose was unknown, a survey mission, a data collection flyby. Its trajectory was not chance. It was a deliberate, gravity-assisted path designed to observe every significant planet in our system with minimal energy expenditure. Its lack of non-gravitational acceleration was not an anomaly. It was a feature of a sophisticated, balanced propulsion system. The Vantablack's surface was not natural rock. It was advanced thermal shielding. The changing chemical signature was not sublimation. It was the venting of different materials, perhaps related to power generation or thermal regulation. The small course correction seen by JUICE was a final adjustment, aiming its sensors or itself toward a new target in the deep void. 3I Atlas is now just a data set, 4,022 astrometric observations, petabytes of spectroscopic and imaging data, a single or a fleeting pass. It offered no clear message. It did not communicate. It simply performed, its actions recorded by our instruments. It forced humanity to confront a profound uncertainty. We now know that the galaxy contains objects that are massive, ancient, and operate according to a physics or an intent we do not understand. The discovery did not answer the question of whether we are alone. It replaced it with a much more unsettling one. What else is out there, passing through our system, silent and unseen? The search for the next interstellar visitor has become the single most urgent quest in science. We are no longer just looking for rocks. We are looking for answers. And we are watching the skies with a new and profound sense of awe and of fear.